Alright, so we're going to look at part 4, in which we vectorize our function from part 3, our surface function, to generate the helical pipe around our curve. So, as I said, we're going to want to vectorize our surf function, so we'll call that surfvec. And we'll set that equal to jnp.vectorize. And we want to vectorize, like I said, our surface function. Then we got to feed it the signature for vectorize, and in that we do a scalar, to an array, size 3. And there we go. So now we can call on surfvec. And if we, so up at the top I did define a variable theta, which is from 0 to 2 pi with 18 points. And that's what I'm going to help use to generate the pipe around the curve. So we can call on surfvec with our t and theta. And this isn't going to work. We're going to have to add a dimension to both t and theta. So we can do that pretty easily. Oh, I thought I put the little arrow in there, I guess not. Alright, so now we have our vectorized function. And I'll call that S1 just so I don't have to type that whole thing out. So now if we look at the shape of that, if I can spell, we can see that our x, y, and z's are at the end. So we want those at the beginning just so we can pull them out. So if we transpose it and then look at the shape of that, it'll flip it so they're at the beginning. So I'll call that S2. Alright, so now I just want x, y, and z. Guess we'll call it x1, y1, z1. And we'll set that equal to S2. And now we can start plotting. So we don't need the actual helix anymore, but we'll copy that. Alright, but first we can do the line. So for I in range, and to do the lines around, we'll do theta dot size. And we just want to plot each line that we're making. And we want to plot them at, we want to plot each x at all the thetas, each y at each theta value, and each z at all the theta values. So now if we take a look at this, I plotted all the lines at all our theta values, and I got rid of the helical curve, so that line's not in the middle anymore. And we can get rid of all those colors if we just do line, color, and we set it equal to white. Keeps it a little easier to look at. So now we want to plot like circles at each point t, just to make it look a little nicer. It'll look pretty clean. So we do pretty much the same thing, but we're going to do it for each t, as I mentioned. So we'll change that to t dot size, and then we want to plot Again, we want to plot all the thetas at each t. So we'll flip these around. And then again, we'll keep it white. Run. And as we can see, that drew in like the circles at all of our t values, and kind of makes it look like a nice pipe around the helix we had. And I think I mentioned this in one of my earlier videos, but if we want it to look a little smoother of a pipe, we can just add more t's. So if I throw 100 points for t in there, and then plot. It'll take a little longer. 100 might have been aggressive. Oh. I'm gonna rerun this. Whew. And now we have 100 points for t. So just makes the curve look a lot smoother, and there's less kind of choppiness to it. And so here we go. That's homework 1.